Welcome to another EWB tutorial. Today we'll be going over Civil 3D. I plan on doing several videos on this program in the near future as well. So what is Civil 3D? This program is made by Autodesk, which is the same company that made AutoCAD. Civil 3D focuses on civil engineering programs revolving around land development, water, and transportation. The program can be used for BIM, which stands for Building Information Modeling, which involves planning and designing by using data from the location or surveying. Alright, let's get started. Let's take a look at the ribbon. So, there's some similar functions with AutoCAD. You can draw, annotate our objects and drawings, as well as inserting blocks into our drawing. However, the main difference between Civil 3D and Autodesk is that we were given new commands and features such as storm sewers, intersections, corridors, as well as looking at surfaces and contours. There are a wide variety of fields within civil engineering that will use this program for their projects. Let's start by adding in data. Before that, we typically start by inserting a known drawing file or by inserting survey points. This data will be added into our database, where we'll have a working folder that will save all of our styles, points, and changes within our drawing. So my first step is I'll be going to the Survey tab on the Tool space. This is also located on the top hand corner by clicking the survey. Here I'll start by making a new local survey database. I'll name this test 2 since I already have test 1. And here I'll need to have set working folder. So I'll click on test 2, select this folder. And so now we need to insert our data. So on the upper hand corner, I'll hit import survey data. For this example, I'll be importing a point file from one of the projects in the EWB club. So first, I'll create a new survey database. I'll name this test 2. Hit OK. Hit next, and now we'll need to insert type data. So as stated beforehand, I'll insert a point file. I'll need to add it in. Here I'll insert road points. Now Civil 3D wants us to know the format of our file, how it's listed. So for point files, there are different ways in which it can be listed, and for the points, they're typically listed as point number, northing, easting, elevation, and description. PNEZD is abbreviated for it. Difference between Civil 3D and AutoCAD is that the points in Civil 3D are classified as COGO points, and here we use Cartesian coordinate system, and we can add point numbers in description, whereas in AutoCAD we have points that simply state where it's located on the XYZ coordinate system. So I'm gonna open my road points text file and check what type of format it is. So prior before to this video, I already checked, and this is representing the point numbers, this first column, and second column is northing, third easting, and the last column is elevations. Each one is divided by commas. So I will go and find PNEZ, comma delimited, hit next. So survey network is a series of interconnected lines that represent the observed instrument setups or stations. For now, I'll just skip it. Right now my settings are good. I can hit no on this. It looks okay. Hit finish. If I zoom in or double tap on my scroller mouse, you can see that these are the points that we have just imported. You can view the points by going into survey or test file, row points text, survey points. You can view it down here, or by right clicking and hitting edit points, and we'll get a new window which we can view our data on here. So this is a relatively small file. We have like about 10 or 12 points. However, some projects can have 50 points or over 100 points, and it might be hard to distinguish them. For example, we can have points that describe a road, as well as points nearby it that represents rivers, and we want to divide it into two different groups to distinguish them. An easy method to do this is by creating point groups. So to do that, we'll need to go to the Prospector tab. Under point groups, we'll need to make a new point group and give it a name. I'll call it random point group, as well as selecting the type of point group that we wanted. I'm not gonna make one because we only have one listed in this file, so I'll hit cancel. Sometimes on the left hand corner there will be a exclamation point or a yellow icon, which is an error. Sometimes you'll need to right click and click the update to fix that issue. Now with our point and point groups, we can create a surface based off of these points. And what a surface is that it's a 3D representation of an area. A surface are made up of triangles and grids that are created from the points that we have just inserted into Civil 3D. To do this, we'll click on Surface, right click, Create Surface. I'm gonna keep it as tin surface, and what tin means is triangulated irregular network. And so tins create triangular surfaces, and the advantages of using tin is that they map out highly variable surfaces such as streams, roads, and lakes, as well as examining localized areas from large-scale maps. Meanwhile, grid surfaces comprise of points that lie on a regular grid, and they're typically used for examining large study areas and for mapping more uniform surfaces. So now I'm gonna name my surface. Hit OK. And surfaces need points so that I can create an area. So I'm gonna go on Surfaces, Definition, and I'll insert my point group into the surface. I'm gonna add my road points here. Hit OK. So we have created our surface, but what happens if we want to change how it's viewed or looked at? We can right click on our surface and go to Surface Properties and change the surface tile into what we desire. Let's try this one and see what happens. I'm gonna keep elevation bonding. Oh, just kidding. I'm gonna keep it contours and triangles. There we go. Alright, so now that we have our surface, we'll need to create a profile in order to showcase the elevations through our points. So in Civil 3D, to create a profile, we'll need an alignment. And basically an alignment is a linear feature for land development, such as road, railroad, water lines, electrical lines. It's pretty much anything that's classified as a line, and we can create a line from our point group. So to do that, we'll go to the Home tab, go to Alignment, create Best Fit Alignment. We're going to use our Kogo points. Road point. I'm just going to give this a name. Alignment test. I think all the settings are okay. But we can also change the style of our alignment and add labels. I'll add major and minor. Hit OK. So here at the bottom is our alignment, which here you can see is represented by this line. And with this alignment, we can now create our profile. To create our profile, we'll go to our Home tab, go Profile, Create Surface Profile. I'm gonna select my alignment and hit Add. For me personally, to make sure my steps are correct, I will check on my elevations and make sure they have various values. This is a good hint to make sure that all of your previous steps have been correct. I'm going to go on Draw in Profile View. You can change some of the styles, station range. I'm going to keep it as stated and just create a profile view. Click on where you want your profile to be in the model space. So here is our profile. Right now our profile looks a little bit stretched and not in the orientation that we would like. We can always change it by clicking on our profile, and on the top hand corner we can go to Profile View Properties, and edit Profile View Style. Here we have information regarding this profile, as well as changing the vertical and horizontal axes. Right now my drawing is set to 1 inch is equal to 40 feet. Let's see if I can change that here. Hit apply. Looks slightly better, right? On a title annotation, I can also change the title up here by going into this icon. Let's change it to Test Profile. Hit OK. Hit apply. We can also shift our grid by moving it up or down, left or right. As well as changing our horizontal and vertical axes. We can also create a best fit profile by clicking on the profile, create best fit profile, hit enter. Surface profile. Everything looks good. I'm gonna hit OK. Lastly, for our profile, we can add labels onto our drawing. So we click on our profile, and we can add tick marks or labels for major minor stations, as well as sag curves and crest curves. So this is a pretty basic Civil 3D tutorial. In the near future, I plan to look more into cross sections, designing roads, roundabouts, storm lines, plotting, as well as maybe even storm sewage, so keep a lookout on our YouTube channel. If you have any feedback or anything you would like to let us know, please leave in the comment section, as well as checking out our website. We plan on releasing more YouTube videos regarding tutorials on several programs, as well as providing resources for our community. Thanks.